first thing you need to do when you have a word problem is you need to indicate what each variable stands for. Once you identify each variable, you need to write a system of two equations that can be used to solve the problem. Once you have a system of equations, you can solve the system. Now, at this point, you have mastered graphing, substitution, and elimination. So at this point, you pick whichever one you want. Whichever one works best for you, that's how you solve the word problem. State your solution in sentence form. We're no longer putting X and Y. We're no longer putting an order pair. Now you have to use a sentence to answer the question. And then check your work in both original equations. Take your X and Y, plug it into both equations, and make sure you get true statements. Alright, so let's look at an example. You are selling tickets for high school basketball game. Student tickets cost $3 and general admission tickets cost $5. You sell 350 tickets and collect $1,450. How many of each type of ticket did you sell? So we have two types of tickets. We have student tickets, we have general admission tickets. So we identify them as X and Y. In the grand scheme of things, it does not matter which one you label for which, because when we get to our final answer, we have to write, we sold this many student tickets, we sold this many general admission tickets. We're not going to put X equals this and Y equals this, okay? So you need to write down X equals student tickets, Y equals general admission tickets. We sold a total of 350 tickets, but we don't know how many of those are students and how many of those are general admission. So the amount of student tickets sold plus the amount of general admission tickets sold equals 350 tickets. There's one equation. Our next equation is student tickets cost $3 per student ticket plus $5 per general admission ticket equals the total amount of money collected, $1,450. Once you establish your system, a system is two equations, you solve. At this point, you get to pick. Do you want substitution? Do you want elimination? What's going to be the best thing for you? In this situation, substitution is going to be easier. Okay? So I have to isolate one of my variables. Always pick the one that has a coefficient of 1 or negative 1. So I'm going to subtract X from both sides and get Y equals negative X plus 350. Since I'm using substitution, I'm going to take the value of X, plug that in for Y in the other equation. 3X plus 5Y. Y is negative X plus 350 equals 1,450. At this point in the game, we know how to solve using substitution. We're going to distribute 5 to the negative X and the 350. 3X minus 5X minus 350 times 5, which is 1,750 equals 1,450. Three X minus 5X is negative 2X. We add 1,750 to both sides, and we get negative 2X equals 3,200. Actually, this is supposed to be positive, so we should be subtracting, not adding. Always make sure you pay attention to your signs so that you do not mess up. Add 17, subtract 1,750 from both sides. negative 2x equals negative 300. Divide by negative 2 on both sides, and x equals 150. Once you solve for your first variable, plug that back in. Negative 150 plus 350 is 200. So our system, or our solution, is how many of each type of ticket did you sell? Y represents general admission. X represents student tickets. We sold 150 student tickets. And 200 general admission tickets. There's no need for fluff, no need for a paragraph. I just need one to two quick sentences telling me how many of each type of ticket that was sold. Alright, so let's try another one. Number 2. Missy Elliott loves to shop at Neiman Marcus. Last Saturday, she bought some pants and shirts for her new video. Each shirt cost $125, and each pair of pants cost $225. She came home with 26 items and spent exactly $4,950. How many pants and shirts did Missy buy? First thing we have to do is identify our variables. So we have X and Y, pants and shirts. Again, it does not matter which you pick for which. You got your X, you got your Y. Alright, so the total of pants plus the total number of shirts that she bought equals 26 items. So X plus Y equals 26. She spent $225 for each pair of pants and $125 for each shirt, spending a total of $4,950. Now that I have my two equations, I have my system. I can solve using either elimination or substitution. In this situation, I would recommend using substitution. Alright, so I need to isolate a variable. It does not matter which one. Just pick one that has a coefficient of 1 or negative 1. So X plus Y is 26. I'm going to isolate my Y. So I'm going to subtract 6X from both sides. And Y equals negative X plus 26. I'm going to substitute that in for Y in the other equation. That gives me 225X plus 125Y, which is negative X plus 26, equals 4,950. Your goal is to have only one variable in this equation so that you can solve for that one variable. I have 225X. 125 times negative X is negative 125X. 125 times 26 is 3,250. And write down the rest of your equation. $225 minus 125 is 100X. I subtract 3,250 from both sides, and that gives me 100X equals 1,700. And I divide by 100. X equals 17. So X represents pants. First thing I can write is she bought 17 pairs of pants. Plug X back in. 17 plus Y equals 26. Subtract 17 from both sides. Y equals 9. And Once you come up with your solution, you plug it back in. X plus y is 26. 9 plus 17 is 26. 225 times 17 is 3,825. 125 times 9 is 1,125. And when you add those together, you get 4,950, which equals 4,950. So I know my solution is correct. You were in charge of decorating the gym for the homecoming dance. You purchased 6 bags of balloons and 5 bags of large sparkling hanging stars, all for $19.20. You soon realized that this was not enough to decorate the entire gym. On your second trip to the store, you bought 8 bags of balloons and 2 bags of large sparkling hanging stars, all for $15.80. What was the price of each item? So I'm going to use B for bags of balloons and S for sparkling stars. Now, of course, you can use X and Y, it doesn't matter. So for $19.20, I purchased 6 balloons, bags of balloons, plus 5 bags of stars for $19.20. And this wasn't enough, so my second trip, I bought 8 bags of balloons and 2 bags of stars for $15.80. So, I need to isolate one of my variables. I'm going to pick S in the second equation simply because that has the smallest coefficient and it will go into everything in this equation. So I get 2S equals negative 8B plus $15.80. And when I divide by 2, I get that S equals negative 4B plus $7.90. Now I know we talk a lot about leaving things in fractions. Well, when you're dealing with money, you actually want to leave it in decimals. So sometimes that rule changes. So I'm going to plug this negative 4B plus $7.90 in for S in the other equation. 6B plus 5S, S is negative 4B plus $7.90 equals $19.20. 5 times negative 4B is negative 20B. 5 times $7.90 is $39.50, and that equals $19.20. Combine like terms, and I get negative 14B plus $39.50 equals $19.20. When I subtract $39.50 from both sides, I get negative 14B equals $20.30. And when I divide by negative 14, I get B equals $1.45. I'm going to take this and plug it back into my original equation. 6 times $1.45 plus 5S equals $19.20. 6 times $1.25 is $8.70. Plus 5S equals $19.20. Each time you do a step, you write it down. Subtract $8.70 from both sides. 5S equals $10.50. And when I divide by 5, I get S is $2.10. So balloons cost $1.45 per package, and stars cost $2.10 per package. This is the answer to my word problem. Let's look at one more. For number 4, I have Kmart has a sale on DVDs and videotapes for Labor Day weekend. Katie bought 2 tapes and 3 DVDs and spent $134. Emily bought 1 tape and 5 DVDs and spent $179. How much does each tape and